All right, welcome back, Algebra 2. Hey guys, we are officially at the end of Chapter 3. We are into Section 6, solving linear systems with 3 variables. That's right. This is a pretty big upgrade, big step up from solving linear systems with just x and y. Now we have x, y, and z. And you'll remember from past section where we were graphing with x, y, and z, and that was that third dimension. Now we are solving for all 3 variables, x, y, and z, okay? So you can take a look at that first little note there. We're going to use the elimination method for solving, okay? And the elimination method, you can remember back to Algebra 1. Basically, the purpose is we are crossing out variables when they share the same coefficient, and that's helping us to drop down the quantity of variables and eventually get down to where we're just solving for a variable, and then we plug it back in and we keep solving until we have all 3 variables, okay? So you'll see that second note. Honestly, guys, I can't stress this enough. This is so important to stay organized. Those of you guys that have been gifted to do a lot of math just in your head, and you kind of have been able to, skip by with just getting minimal amount of work, and then somehow you still get the right answer, it's going to be very difficult to do that, okay? So you must stay organized, and that means writing everything down, okay? Everything down. That is not going to be easy come test time if you think you can write a couple things down and still get away with it. All right, so write everything down. You're going to find that these problems can take a good deal of space. So do not cramp your work altogether, because then it will get very confusing about what equation is now being used for what purpose. Okay, you're going to see what I mean here pretty soon. All right, so one of the last notes we have, basically, you will start by trying to reduce a 3 by 3, which means x, y, and z, down to a system that is a 2 by 2. All right, could be x, y, could be y, z. Kind of depends on what the coefficient is. All right. Remember, you can only solve for 1 variable at a time. So that means you're going to have to find a way to eliminate 1, drop it down to 2, then eliminate another 1, and that gets 1 variable solved for. Okay. Once you have that variable, you will then plug it back in to a 2 by 2. That's now going to allow you to have 2 variables solved for. Once you have 2 of the 3, you will then plug those 2 back into one of the original 3 by 3s, and that's going to give you the third unknown variable. Okay, so here we go. And of course, kind of goes without saying, but I'm still saying it every time. You guys got to watch all these examples, all right? You got to copy all these notes down. You got to watch all these examples. Here we go. All right, first example, make sure you have some space to write these notes. All right, here we go. So one of the things that I recommend right off the bat in the beginning is numbering the equations. All right, numbering the equations so that I don't have to keep saying all of the equation. I'm just going to say equation 1, equation 2, equation 3. So that's why I just put 1, 2, and 3 in a red pen by those equations. All right. Now we're going to change the color here to blue. So the first thing that I notice is that equation 2 and equation 3 both have a z that has a coefficient of 1. So that means I'm going to take those equations and I am going to use them first and eliminate z. By the way, normally you will never try to eliminate a variable from all 3. There will come a time where it works, but you'll notice many times it won't work. So go 2 equations at a time. So 2x plus 3y plus z equals 1. And we have a negative 3x minus 4y plus z equals 4. Okay. Now, how am I going to eliminate the z's? Well, they're both the same sign. They are both positives. So that means I will be using subtraction to eliminate z. All right, so now we go variable by variable all the way down the line. 2x minus a negative 3x gives you 5x. Don't forget negative, negative, make a positive. Okay? Now a positive 3y minus a negative 4y, same thing, gives us a positive 7y. Now z minus z, they will get crossed out. Okay? And now we have 1 minus 4 giving us a negative 3. Now what I'm going to do is I'm going to label this equation equation 4. Okay? So now we actually have 3 equations that we're going to be, or sorry, 4 equations that we're going to be dealing with. Now what we need to do is we need to pick the second variable that could get eliminated. And what I have chosen here is I'm basically going to try now to eliminate z from equation 1 and equation 2. Okay, so let's get a little bit of space here. All right, so equation 1 is the negative x plus y plus 2z equals 7. And now I'm going to take equation 2, but I'm going to put it in parentheses. 2x plus 3y plus z equals 1. And why am I putting this in parentheses? Because I cannot immediately go and eliminate z. You'll notice in equation 2, z has a coefficient of 1, but in equation 1, z has a coefficient of 2. So I can't just eliminate that. That means I must multiply all of equation 2 now by the number 2. So basically what this means is I'm going to have to distribute a 2 into every part of the equation. All right, and now after we do that and we distribute a 2 through everything, this is what comes out. We have a 4x plus 6y plus 2z equals 2. So basically we're saying that this up here created this guy right down here. Okay, so follow all along with me. Now, over to the side, just so you can really see exactly what we're dealing with, we're going to take equation, let's see, which equation was that? Equation 1. All right, so we have negative x plus y plus 2z equals 7. And underneath it, we're going to put 4x plus 6y plus 2z equals 2. Now you'll notice that's the equation I just created. All right, look at everything on the left-hand side. Now look at it over on the right-hand side. And now you'll see that I have the same coefficient with z. They're both positives. So that means to get my answer, I'm going to have to, again, subtract. And you'll notice I always put that in parentheses, that subtraction, because I don't want to get confused with where did that negative sign come from. Okay, so now we're going to subtract all the variables away from each other, and let's see what comes up. All right, we get a negative 5x minus 5y. The two z's will cross each other out, equals 5. Okay, now we officially now have our 5th equation that we need. We had the original 3, we created 4, we created 5. Okay, now why did we do all of this work here? Because now we're going to take equation 4, you'll notice is 5x plus 7y. All right, let's stick to that green color. Let's do that over here. Equation 4, which is 5x plus 7y equals -3. A little more space. Okay, and then underneath it, we're going to have -5x minus 5y equals 5. So now I'm using equation 4 and equation 5, and you should now hopefully clue in and see why am I doing that? Because look at the x's. Now I have the same coefficient, but you will notice that the sign on these guys is opposite. There's a +5 and a -5, so I have to use addition to get these guys to be eliminated. Now you'll see that I have 7 minus 5, which is 2y, equals a -3 plus 5, which is 2. And now I'm down officially to one variable that I can solve for. So what is y? Y equals 1. All of that work right there was just to get down to solve for one variable. But once you have one variable, it starts to work out a lot faster. Now, where am I going to put this y equals 1? I'm going to put it right up here into that guy. Okay, so now off to the side, I'm going to write, I have a 5x plus 7 times 1 equals -3. Solve that, and you will now get down to x equals -2. Now, guys, we have 2 of the 3 variables that we need. Now what do? We got a tiny bit of space left. So what I am going to do is I'm going to take the y value, because I know that it's 1. I'm going to take the x value, because I know it's -2. I'm going to take those guys, and I am going to plug them in to equation 2. Now, why am I picking equation 2? Honestly, I'm picking it because everything in it is a positive, and it's equal to a simple 1. You could pick any one of the first 3 equations, 1, 2, or 3, but I'm picking 2 because really it's the easiest one. So let's do that. All right. Now we're going to plug all of that in. So we have 2 parentheses, fill it in with -2, plus 3, fill it in with 1, plus z equals 1. You get -4 plus 3 plus z equals 1, and z equals 2. All of that work right up there, guys, so that now we have all 3 variables. Now, I want you to understand, not every problem is going to take all that work, but I started it off with essentially probably the hardest example problem so that you could see what I meant by being organized, writing everything down, and take your space, spread it out. Okay? All right, that's the first one. Let's move down here. This one, I promise, it'll go faster. All right, so now let's see in my notes here. All right, this one right here, let's start by figuring out, is there a variable I could eliminate right off the bat? We could eliminate y. All right, we could have right off the bat use, let's label our equations 1, 2, and 3. Right off the bat, we could eliminate y from equation 1 and equation 2. So let's write that off to the side. 3x minus y plus 2z equals 4. 2x minus y plus 3z equals 7. How am I going to eliminate it when it's the same variable? Or sorry, the same sign? I use subtraction. All right, so then we get x, the y's are eliminated, minus z equals -3. Okay, so now what I have is my brand new equation 4. All right, now let's take a look. And we will be eliminating y in equation 3. And what other equation am I going to use? I'm going to use equation 1, and I'm going to use equation 3. Okay? 3x minus y plus 2z equals 4. That's equation number 1. And then underneath it, let's see, we have, get a little bit more space here. All right, we have a equation 3, negative 9x plus 3y minus 6z equals negative 12. Okay, all right. Now we need to take a look at equation number 1 and realize, how can I eliminate y? I have to multiply everything in it by 3. Distribute the 3 here, 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 and here. All right, when I do that, this is what will fit it in here. We'll fit that new equation right down here. Okay, you'll see we now have a 9x minus 3y plus 6z equals 12. Now, if you look closely at this, the reason why I wanted to fit it in there directly above it, everything is matching. Like everything is matching. You have a 9x, you have another 9x. You have a 3y, you have another 3y, a 6z, another 6z. I know I'm way too hyper about this, but you have to notice that. All right? Everything matches up perfectly. So what do I do to eliminate literally everything? We're now going to add, and everything will drop out. Everything. So that means we have 0 equals 0. If this is what you get, you now have officially all numbers. All right, this is an infinite solution. Okay, that is what it means when you eliminate every variable and you actually now have a number equaling the same number. 0 equals 0, yes, that is true. So all numbers, infinite solutions is your answer. All right, let's move down into now number 3. Okay, so, oh, look at that possible note right there. If it's possible to eliminate all 3 variables, we just did it. You're only going to have 2 possible answers. What might we get? Infinite, or we might get none, no solution. Okay, let's see what we get here. You know what? This note probably should have been in the upper problem right there. So let's go ahead and take this guy, and we're going to copy him, put him up here, because he belongs up here. That's right. Does not belong down here. All right, delete him. There we go. Let's move on to the third example. Now here is something special that you should notice. Remember in the above part of the notes, I said rarely ever will you have a variable in all 3 triplets that could be eliminated at the same time. But look what we have. We have an example where all 3 triplets possess x with a coefficient of 1. So right off the bat, we could jump in and take, we got equation 1, 2, 3. Now we're going to take these 2 guys, and they will create a brand new one. So right off the bat, equations 1 and 2, we could eliminate x, and we're going to use subtraction to eliminate x. And what is that going to get us? That is going to get us a negative y plus z equals 4. So what I want you guys to see is I took equation 1 and equation 2, and I used subtraction. All right, so that x is dropped out. 2 minus 3 is negative 1. 3 minus 2 is positive 1. 9 minus 5 is positive 4. That's how I got that brand new equation. Then I'm going to take these guys. I'm going to take equation 2, and I'm going to take equation 3. I'm going to do the same thing. Use subtraction. that's going to create, again, a negative y. Now plus 3z equals 10. Now you should notice, guys, I still have matching variables, a negative y and a negative y. That could be eliminated. All right, so what am I going to do here? I'm going to use subtraction again. That's going to cross these guys out. All the x's, remember, they were officially crossed out right at the beginning. Now I have a negative 2z equals negative 6z equals 3. Bingo. I officially have one of my variables solved for. Let's take this guy, plug him in right there. That's an easy z by itself. And you get negative y plus 3. Negative y plus 3, we plug that in, equals 4. Now what is y? Y equals negative 1. All right, remember I plugged in that 3 to the z, so I got negative y plus 3 equals 4. Y is negative 1. Now I have z, I have y, and now I need to plug it into one of my equations. Well, for starters, all of the x's are by themselves. Why don't we just use equation number 1 here, shall we? All right, so let's go. X plus 2 parentheses negative 1 plus 3 parentheses 3 equals 9. All right, x, sorry guys, x minus 2 plus 9 equals 9. X is 2. That is simple enough, just as that. All right, so the reason why I wanted to show you this example here, example number 3, was to show you if they do possibly give you a variable right off the bat that is the same in every triple, this is how you would solve it. Okay? All right, we are moving into our very last example problem. Classify the system. Here comes that note again. It might be possible to eliminate all 3. Let's show you what it looks like to eliminate all 3. Okay? But right off the bat, don't forget, label the equations 1, 2, and 3. Okay? So it looks like I could eliminate. How did I do this one? I chose to eliminate y from equations 1 and equations 2. All right? So let's show that. If I'm going to eliminate y, in equation 1, I have a coefficient of 4 for the y, but in equation 2, I have a coefficient of 2. So what does that mean I'm going to have to do to equation 2? I'm going to have to multiply everything in equation 2 by 2. All right. So here we go. We have equation 1, 2x plus 4y minus 2z equals 4. And then I'm going to put in parentheses negative x minus 2y plus z equals 4 and multiply everything by 2. All right. That is now going to give me a negative 2x minus 4y plus 2z equals 8. All right, now what you should be looking at here is this equation right here, this equation right here. Okay, because what you need to see, if you look really closely, every variable again matches up. Okay, and if I were to use addition, you're going to see this crosses out, this crosses out, this crosses out, and I'm left now with 0 equals 12. 4 plus 8. Does 0 equal 12? No, it does not. Therefore, we are now looking at a no solution because 0 does not equal 12. Whew. All right, guys, that covers all of section 6. Yes, that was a lot. I understand. But watch it, pay attention, copy it all down, and be ready. Okay. All right, guys. We will see you in the next one.